Okay. Thank you, everyone, for joining us. We're here for combating hackers, implementing real-time versus reactive responses with Jenny Poisson from BAE Systems. My name is Steph Daly. I'm the Global Competition Coordinator for CSAW. And so, yeah, again, thank you so much for joining us. Before I introduce Jenny, just a note that Jenny will have some time for Q&A at the end of this session. And so if you want to pop questions into the Q&A, that's the best place to do it. There's a little toolbar for that. There's a chat as well. I'll be on chat if you guys have any questions or issues, but again, any questions related to the talk, best if you can get them in the Q&A. If not, throw them in the chat, and I'll keep note of that. Yeah, I'd love to do a little introduction. So Jenny, again, as I mentioned, is with BAE Fast Labs, BAE System Fast Labs, and there she serves as the technology development manager, and she guides teams in executing complex research plans. She has been developing and executing strategy to expand BAE Systems' existing technology, and doing a lot of work in transitioning new technologies to operational platforms. I hope I kind of got that right for you, Jenny. But really appreciate Jenny's time. Again, appreciate you as the audience being here today on Thursday. And with that, I'll hand it over to you, Jenny.
Great. Thanks for the intro, Steph. Good afternoon. My name is Jenny Poisson. I am the Tech Development Manager in BAE Systems Fast Labs. A little of my background was already shared by Steph, so I'll just share a couple more tidbits. So I spent 14 years as a military officer serving in the U.S. Air Force, primarily in the space and missiles career field. So designing and building new satellites. I ended up winning Space Officer of the Year award for the Air Force, and then was sent to the Pentagon to work for Secretary of the Air Force, Secretary James. From there, I was detailed to be a program manager and spaced me for the Scientific Advisory Board. So the Scientific Advisory Board, basically, each service has one. And they research whatever the biggest problems are as identified by that service chief. So they'll have maybe like 3 or 4 different large research projects a year. They pull in experts from academia, from industry, some people within the DoD. The initial study that I was involved in quite a few, but the first one was to be a space me and program manager for a study on cyber threats of embedded systems on air and space systems. And so within the first, I would say, month or two of that analysis, identified a gaping hole in how we tested our system, and came up with a methodology along with one of my coworkers in order to bring a bit more technical rigor to the process. And so from there, I ended up kind of getting sucked more into the cyber world and a little less on the satellite development side. So that's kind of a bit of my background. Today, I'm going to talk to you about implementation of real-time versus reactive responses. And in the next slide, I'm going to go over what I'm going to talk about today. All right, so first we're going to talk about BAE Fast Labs. Who are we? What do we do? Then we'll dive into some notorious data breaches, how they did it, how it could have been prevented. And then we'll transition to embedded system hacking. So this is different types of commercial vehicle exploits. And then we're going to look at real-time response and what our, as in BAE Systems, approach is to preventing, alerting, and responding to attacks in real time. And then, as Steph mentioned, we'll have some times for Q&A at the end. All right, so how are structured? So there's big BAE, which is BAE Systems Inc. which is split into 3 different areas. So we have platforms and services, we have intelligence and security, and then we have electronic systems. And that is where I live and where Fast Labs lives. At electronic systems, our mission is we protect those who protect us. And as a military veteran, that is near and dear to my heart. So I'm very happy to be working at BAE. The mission and their mission means a lot to me. So this chart here shows the business areas within electronic systems. So you'll see that Fast Labs is in the center. And this shows that we support all of our business areas. So our customers are both internal and external to BAE. So all of our research and development gets fed into all of the systems that we build ourselves. And then we also help outside customers as well. I'm going to get a little bit more into Fast Labs on the next slide. All right, so Fast Labs is our rapid research and development arm of the company. We collaborate with the different business areas that you saw on the last slide in order to develop and implement advanced technology capabilities in the areas of advanced electronics, autonomy, cyber, electronic warfare, and sensors and processing. We also work very closely with universities, venture capital firms, and startups so that we can bring these game-changing technologies to the front lines faster. All right, so as I mentioned before, we are the rapid R&D arm of the company. This here is a dive into cyber technology, which is one of the business areas within Fast Labs and where I work. So our main focus is on developing new offensive and defensive cyber EW technologies to meet warfighter needs in a constantly changing threat environment. If you're not familiar with the term EW or electronic warfare, it is the ability to use the electromagnetic spectrum, like signals like radio, infrared, or radar, or using directed energy to protect military assets. The chart on the right shows some of our cyber focus areas. In the interest of time, I'm just going to pull a few of them out. So if we look under platform cyber resilience, these advanced solutions help create greater resiliency in cyber attack prediction, detection, automation, and control in networks and non-traditional cyber environments. So when I talk about non-traditional, this is including both military and commercial platforms. Under cyber platform effects, here we're leveraging BAE Systems' experience in automated reverse engineering and cyber weapons development. And this really acts as a foundation for rapid on-demand production of tailored cyber weapons that are usable in both offensive and defensive military missions. Next up, under complex systems and tools. So by its very nature, advanced cyber technologies incorporate an ongoing flow of complex systems and tools to be employed at different points and under different circumstances to overcome cyber conflicts. So one example here is embedded cyber technology for chip and board level intrusion detection and response that allows that really deep protection of embedded computing devices. And we'll talk a little bit about embedded systems in a couple slides. So in addition, our cyber warfare professionals, they're now developing several new cutting edge tools, including predictive weapon effects, additional reverse engineering solutions, supply chain inspection, and remediation technologies. Under cognitive cyber, this combines BAE Systems' knowledge of offensive and defensive cyber operations with our experience in third wave AI. And here we're innovating and developing and delivering cyber technologies that respond at the speed of an attack. All right, now we're going to get into the fun part. So in the next couple slides, I'm going to walk you through some pretty historic cyber events. As cyber professionals and systems engineers, it's really important to know what exploits are out there and to learn from them. So exfiltration occurs when malware or malicious code carries out an unauthorized data transfer. It's also known as data theft. The key point here, if you have information, you are a target. There are a number of adverse effects to such attacks. I listed a few of those below. Some of these you might be familiar, some of the cases you might be familiar with already, but I'm going to walk you through what happened, how adversaries were able to get in, and a few things that organizations could have done to either prevent or buy down the severity of the attack impact. So if we look at loss of intellectual property, the example I have here is 2014 Sony Pictures. There was a massive security breach where a hacker group stole data, released it to the public, and then erased the data from Sony's systems. So the data involved included pre-release movies, employee private information, salaries, emails, and other sensitive documentation. The attack also included corruption to the disk drives by removing information necessary for boot up. And then subsequently, Sony spent about $15 million to fix their security infrastructure. And then overall, they estimate around $41 million of loss due to the event. So there's no shortage of investigations and research on this case. Generally, it was determined that hackers spent at least 2 months copying the files. The hacker group that claims responsibility says they had access for a year and were able to steal over 100 terabytes of data. So they were able to gain access to user credentials via phishing emails and fake websites. From there, they were able to establish a presence on the network and poke around for weak points. According to the hacker group, they were able to exploit a vulnerability within the SMB, which is the server message block, in order to carry out the attack. So the SMB is a file sharing network. So this would be stuff like community printers and share drives. And then once a SMB vulnerability is exploited, you can move laterally through different connected systems. So what could they have done to prevent some of this? Not an all-inclusive list, but some of the stuff that they could have done was, this particular event, it happened in November of 2014. If you rewind back a few years to 2011, Sony's PlayStation network was compromised. Completely unrelated event, but it could have served as a wake-up call to implement measures to protect corporate and customer data. So they did not learn from, previous exploits. A second thing they could have done, as I mentioned before, the hackers gained access to user credentials and then established presence on the network. Well, had they implemented some sort of multi-factor authentication. So, in addition to just having to put in a username and password, you could also use like a smart card with a certificate or an OTP token. So the OTP tokens are those, it's like a pseudo random number generator. So you'd have to do that. And then every so often it asks you to put your number in. Or they could use some sort of biometric device in order to have that multi-factor authentication. There's also several data protection controls that could have increased or increased the security, reduced the severity. So they didn't have any encryption on the files, which could have made it a lot more difficult for hackers to open and view the data. Always a good idea to encrypt anything that's sensitive. Implementation of network perimeter monitors to detect sensitive information moving across boundaries. they could have monitored information leaving the network. Hackers sometimes use encrypted channels to bypass network security devices. So being able to detect any unauthorized or rogue connections is really important. And then just like malware detection capabilities. So there's signature-based tools that will only catch already known malware, but then there's also in existence non-signature-based tools that can detect if there's an executable within network traffic. So moving on to loss of consumer confidence. The example I have here is with Equifax. So in 2017, there was a data breach within Equifax, which resulted in the exposure of personal data from about 148 million individuals in the US. That accounts for about 50% of American adults. In addition, there was millions of foreign citizens that were impacted. Overall, this exploit ended up costing the company $1.4 billion. So the details here, the breach occurred through a third-party software exploit that had been patched. However, Equifax had not patched it on their servers. The vulnerability was discovered by the third-party software company, patched immediately. So this happened in March of 2017. Equifax was breached in May of 2017. And then they didn't discover the breach until July. So it had been about 76 days between being exploited and the discovery of the exploit. Overall, there were 34 servers in 20 different countries used during the breach. So attribution here is very difficult. In terms of prevention, you know, hey, patch your computers, right? So simple patch in March could have prevented this initial access. In addition to that, the breach was actually pretty easy to pull off. In this case, they had a very insecure network design. There was not sufficient segmentation within their overall design. So that makes it really easy for an adversary to move around once they initially get in. There was inadequate encryption of personal information, and they did not have effective intrusion detection mechanisms on their networks. The final example I have here is impacts on national security. This example is on the 2015 attack on the Ukrainian power grid. So this attack was really sophisticated. I could probably talk about this one for hours because it's very interesting, but I'm going to kind of give you the higher, you know, I only have a half-hour block version of this. So in this case, hackers compromised the information systems of 3 different energy distribution companies in Ukraine, and they temporarily disrupted the electricity supply to 230,000 people. So I don't know if you're familiar with Ukraine or not, but their average temperature in December is 31 degrees Fahrenheit. So it's pretty cold. Luckily, power was only out for 1 to 6 hours. However, the control centers were not fully operational until several months later. So diving into the details, this attack started with a spear phishing campaign to IT staff and system administrators at the 3 different distribution companies. So if you're not familiar with what spear phishing is, it's targeted to very specific individuals, where phishing casts a broader net. So if you're going to do a phishing attack, you know, maybe you send something to everyone in the company. But with spear phishing, you're targeting very specific individuals. So in this case, they only sent stuff to sysadmins and IT staff. So these attackers did their spear phishing campaign. Someone took the bait, and then the attackers were able to exploit a known vulnerability within the macros feature in Word. So if you're not familiar with what a macro is, so in Microsoft Word, you can create macros, which is a series of commands and instructions that you group together as a single command. and then a task is automatically completed. So you can do stuff like, automatic formatting and stuff like that. There's a lot of different things that you can implement within a macros to include bad stuff. So I imagine that, when they receive the email, there's a pop-up or a bar across the top that says enable macros. They click on that, and then the exploit starts. Okay, so anyway, the companies in this case, so that you have the exploit, the bad guys are in. In this case, the companies actually had really good segregation on their networks with a firewall. So the attackers were only able to get to the corporate networks. Since they hit that roadblock, they decided to revector, conduct some recon while they were in the corporate networks, and they were able to study and map out the networks and gain access to the Windows domain controllers to siphon operator credentials. So from there, they were able to remote access to the VPN, and they used these stolen credentials they got off of the corporate network to be able to remotely log into the SCADA network, which controls the electrical grid. And SCADA is just kind of like a generic term for a control system architecture. It stands for supervisory control and data acquisition. So a lot of your industry type systems are set up as SCADA. So if you look at like water management systems, electrical power, traffic signals, mass transit systems, environmental control systems, manufacturing, a good majority of these, not all, but a good chunk of these are on SCADA systems. So anyway, so once they're into this SCADA system, they go in and they disable the backup power supplies at the distribution centers. And then they went in and overwrote the firmware on critical devices at 16 of the substations. This left the substations unresponsive to any remote commands from operators. And then this means that the workers would need to control the breakers manually. And some of these were in very remote locations. Before they took the substations offline, they also launched a telephone denial of service attack against the customer call centers to prevent customers from calling in to report the outage. And this brought them a little bit more time to carry out the attack without someone noticing. The way the telephone service center was set up, basically the bad actors just flooded the call center with tons and tons of phone calls. So none of the real calls from customers could get through. So after they completed the outage, they used a piece of malware called KillDisk to wipe the files from the operator stations to make them completely inoperable. So KillDisk, if you're not familiar, this wipes data in essential system files, which causes the computers to crash. And because it also overwrites the master boot record, the infected computers could not reboot. This also wipes the tracks of the hacker, making attribution really difficult. So in terms of prevention, the control systems in Ukraine were surprisingly secure. They're very well segmented from the control center of the business networks. They used very robust firewalls and had really good system logging capabilities. And they also had a manual backup for the electrical grid. Workers, however, were logging remotely into the SCADA network that controlled the grid. They weren't required to use that two-factor authentication like we talked about a little bit earlier. And they allowed the attackers to hijack their credentials and gain crucial access to the systems that controlled these breakers. So basically they hacked in and shut all the breakers off. Anyway, in addition, some better network security monitoring may have identified the hackers. They were inside the business system side. They were there for 6 months. So that's the kind of like the high level view of the Ukrainian power grid hack. But the key takeaway here from all of these examples is that robust security up front could have either prevented or reduced the severity of attacks. All right, so moving on to embedded system hacking. So an embedded system is a computer that has a dedicated function within a larger mechanical or electrical system. Embedded systems in automobiles include things like airbags, anti-lock brake systems, cruise control, rain sensing wipers, in-vehicle entertainment, backup collision sensors, navigation systems, your tire pressure monitors that tell you when you need to put air in your tires. The list goes on and on. So my point is there's a lot of embedded systems in vehicles. So as with traditional network hacking, the sequence of an exploit would be something like this. You'd identify your entry points. I have some examples in the diagram to the right. You'd execute the remote attack. So you'd be injecting your messages into the vehicle's network. And then you'd bridge to the desired components or a particular embedded system in order to produce a desired effect. In a number of studies and demonstrations, researchers were able to demonstrate vulnerabilities within vehicles, and I have 2 examples here. These will be a little bit quicker than the last ones. So in 2015, there's 2 pretty famous hackers, Charlie Miller and Chris Velasek. They targeted a Jeep Cherokee that was being driven by a willing participant, and they were able to use a laptop and the internet to execute the exploits on the vehicle. So they sent commands through the entertainment system to dashboard functions, steering, brakes, and transmission. They did all sorts of things to this poor willing victim. So they blasted the air conditioning. They were able to change the radio station, crank up the volume to music that the person didn't like, and then the driver could not adjust any of the controls. Windshield wipers were turned on. There was wiper fluid kept squirting everywhere, inhibiting his visibility. Hackers were then able to display their photo on the digital display, and they were also able to disable the transmission. So after this demonstration, Chrysler recalled about 1.4 million vehicles to implement a security update to fix the flaw. However, a year later, those 2 hackers noted that the hack they used was still possible in the Jeep models that they tested. And this probably has to do with something with, segmenting your architecture. For the Virginia State Police and MITRE Corporation example, this one is really interesting because the exploits were carried out on a non-networked car. So they used a 2012 Chevy Impala and a 2013 Ford Taurus in this demonstration. This controlled attack required in-depth knowledge of the car model's electronics, and it was also physical hijacking where a Bluetooth or cellular device was implanted into the vehicle. The researchers were able to make it possible to shift gears from park to drive. They caused a spike in engine RPMs. They caused the engine to accelerate without applying a foot to the pedal. They were able to cut off the engines completely. And then they also, or MITRE also wrote code that that was able to pop the trunk and turn on the windshield wipers and squirt wiper fluid, much like the Jeep exploit. So attacks can vary from very annoying, like loud music, to critical safety issues. So there's a lot of interest in being able to prevent these exploits. However, most available capabilities are post-mortem only. So that it tells you, the intrusion detection system would tell you that something bad happened after the fact. So, what is BAE doing to protect our systems that we build, and how do we protect our operators from similar attacks? So this here is Fox Shield Cyber Resilience System. This was developed by BAE to provide military platforms with better detection capabilities, attack warning, and mitigation. The solution here provides a real-time cyber threat detection, response, and recovery capabilities. So we're able to alert when something is happening. It's platform agnostic to be quickly and easily transitioned to new platforms. It can be integrated into ground, air, or space vehicles so that we can protect our warfighters and platforms from cyber attacks that are designed to access and degrade our mission capabilities. This can be implemented on existing platform computer systems, or it can be a standalone solution that provides protection while limiting impacts to size, weight, and power constraints. It's a really mature detection capability with a technology readiness level of 8, or TRL 8. If you're not familiar with TRLs, it's a method of estimating technology maturity. Levels are determined by what we call a TRA, or a technology readiness assessment. So it's a government assessment, and it examines programs' concepts, technology requirements, and demonstrated technology capabilities. If you look at TRL 1, that's the lowest level of technology readiness. This is where scientific research begins to be translated into applied research and development. So an example might be like a white paper, paper studies of a technology's basic properties. At TRL 8, the technology has been proven to work in its final form and under expected conditions. In almost all cases, this TRL represents the end of true system development. So examples would include developmental test and evaluation of the system in its intended weapon system to determine if it meets the design specifications. This is really a game-changing technology that I'm really proud to be a part of. It's just really cool, and no one else is doing it. So that's always a fun thing to be a part of and to work on. So this overall concludes my presentation and my allotted time. I'm happy to entertain any questions you might have. We also have a virtual booth set up for tomorrow for BAE. If you want to chat with me or one of my colleagues, we'll be happily waiting in the booth for you.
Yeah, that's a great suggestion, Jenny. Thank you. I was gonna mention that to folks, that as a reminder, we've got the industry fair tomorrow, and as Jenny just said, BAE has a booth, so be sure to stop on by. And we probably have about 9 minutes if folks want to pop some more questions in the Q&A. There is one here, and it's, have you heard or had a chance to analyze the Stuxnet virus that attacked the nuclear enrichment centrifuges of various countries, example, Iran?
So I have. It's been a while since that has happened. So I don't have a lot of that information on hand in terms of how they were able to get in and mitigations and stuff like that. But that is another very interesting one to research. There's no shortage of white papers and analysis on that, and I'm sure if some of the other folks online are not familiar with that case, I would encourage you to look it up, right? So just try to pull from as many different historical examples as you can, so that when you go out and you graduate school and you go out to the working world, you make sure that the organizations you're working for aren't repeating someone else's mistakes, because we see we see that a lot. Even some of these examples that are completely different, it's like, okay, well, segmentation or two-factor authentication. So there's a lot we can learn from studying history in general, and cyber is not a exception to that.
Yeah, I was thinking back, Jenny, when you were talking about the attacks in Ukraine. I guess it was now a couple of years ago, but Andy Greenberg, who was a journalist for Wired, had won our cyber journalism award for reporting on that.
Mm-hmm.
And I was like, yeah, it all comes around. Yeah, and there's been, of course, right, like aftermath from that. Let's see. One more question, more related to.
Yeah, I can see it.
Great.
So do you see more people in industry with higher education, for example, MS, PhDs, or certificates? We kind of have a mix. So I have been in a position where I hire people. I've hired people with undergraduate degrees and master's degree, like the whole gamut. Um, I am a big fan of free education. There's a lot of different companies, like they will hire you as, a bachelor's degree. We don't want all PhDs because, or most companies don't want all higher education because you have to pay them more, and not every company is going to be able to afford that many people. So we need people at like all different levels, and we need, young, fresh ideas coming into the company. And of course, like education is evolving, and some of my smartest folks are undergrads that or someone just finished their undergrad, walking in, and I mean, you can contribute at any different level, but there's, I think I started saying, like, a lot of companies, they'll bring you in and they have education programs. So BAE does have an education program, where we'll pay for your master's degree or we'll pay for your PhD. So I always encourage, and I have teenagers, and so I encourage them, like, hey, get your undergrad and then go work and get someone else to pay for your master's degree. So I personally, like, I have an undergrad. I have done a number of different master's programs, and altogether I've spent $900 on my education. So I've always said yes to education, to certifications, especially if someone else is paying for it. So there's my tip. All right, possibilities to migrate to a full Linux suite instead of Windows environment for all government offices. Well, I'm not savvy on all government offices and all of their different operating systems, but I would imagine that it's one of our favorite sayings, when you're in R&D, is like, it depends, right? So it depends, like, some systems, depending on when they were built, you might not be able to migrate them to either a new version or a completely new operating system. It's really gonna, it's gonna depend on a lot of things. So yeah, so it depends is my answer to that one. Any add-ons, but certainly if you guys think of questions, between today and tomorrow, again, we're in the booth, and you can kind of get into contact with us there as well.
Thank you so much, Jenny. This was great. To the audience, appreciate you guys being there, and just another reiteration of BAE being there tomorrow, so be sure to check them out. Up next on the agenda, starting around 2 p.m., is a talk on gamification from IBM, so you guys can join us in the auditorium for that if you are free. And once again, Jenny, thank you so much for your time. Really appreciate you being here. Really interesting talk. I think it gives a lot of folks some food for thought as they move forward in their careers. And thanks so much, everyone.